All right, well, here we go. We're going to go through some examples of some problems from the review. And without further ado, let's do this. All right, number 3, it says a central angle theta of a circle with a radius 6. So I'm just going to draw, when you have a problem like this, just draw the things they have. So central angle means it starts in the center. It has a radius of 9 inches. All right, subtends an arc that is 20 inches long. All right, so we're going to have subtends. That means it's going to hit a arc that has 20 inches long. All right, 20 inches long. And we're going to find this angle theta. All right, so what do we know? Well, first off, what we know is we have this arc length, and what we know is that the arc length of the whole circle, so 2 pi r, all right, because that's the circumcenter, that's the circumference of a circle, is to the whole entire circle. Let's put this in degrees, so is to 360, all right, as this right here, this arc 20, all right, is to the angle that we have right there. All right, so the angle that we have right there. Okay, so what we want to do is we want to figure out what this angle is. So the arc length of the whole circle is a 360, and so this is the arc, and this is our angle. And so we're just going to make a proportion. And you can do this with any circle with arc lengths and whatnot. And so now we want to solve, and we're just going to plug in our values. So our r is 9, so we're going to have 18, because r put in there for 9, 18 pi, all right, times 360. And that's going to equal 20 over our theta. And this is the angle we'll be looking for. So the angle is that one in the middle. And so next thing we're going to do is we're going to cross multiply. So if you take this right here, we're going to take 20 times 360. All right, we're going to take 18 pi times the angle. And now we're going to solve for the angle. So our angle is going to equal 20 times 360. All right, so you're going to need your calculator. 20 times 360 over 18 times this pi. All right, so let's put that in our calculator, see what we get for an answer. All right, and when we have that, we have 20, all right, times 360, all right, divided by 18, divided by pi, and that should give us 120, all right, at least that's what I got, 127.32, and let's see, that's going to be in degrees. So 127.32, and what do you know, bada bing, bada boom, that's what we have for our answer. Okay, so set up a proportion, all right, knowing that the circumference is to the whole circle as the arc length is to the central angle that you're looking for. All right, so that's how you find central angles given your information about the circle. All right, so next one. It says describe the horizontal shift of a graph of G with respect to the graph of F. So right here, okay, we want to describe what horizontal shift of the graph of G with respect to the graph of F. So how are we shifting this? All right, where is it shifting to? So right here, we have this graph, okay, and we are going from graph of G with respect to the graph of F. So, so from here, how are we moving this? So how much is it? Where is this graph moving? Well, we want to find our C value. Okay, our C value in this case is 3. However, when you want to figure out anything inside, our horizontal, our phase shift, it's sometimes called phase shift. Okay, the phase shift or PS. Okay, which is also known as the horizontal shift, right here, is that we want to solve for this value right here. Essentially, what are we doing to the original value? So when we're doing this, we normally have like our cosine of x, all right, and then we say, okay, this is our original, and we have x sub 0, and we always take the inside, and we say, okay, we have pi x plus 3. And now what we want to do is we want to go through this process. So we're going to take x3, and we're going to subtract 3, and then we're going to divide by pi. And that is what's going to be our next shift. So what we have here is we're dividing by pi, and so we want to know is what are we adding here? So I'm going to just simplify this a little bit farther. And so we have x sub 0. So whatever that original from cosine is going to be, all right, we're going to divide by pi, but we're also going to divide minus 3 over pi. So we're looking to see a horizontal shift is what are we doing to the original value? What are we adding or subtracting to the original value? So this horizontal shift, all right, or phase shift is what are we adding or subtracting, all right, to the original inputs, okay, and that in this case is x, so the original inputs. So in here, well, we can see when we solve for our original, we always take the value inside, all right, whatever we have there, and we solve for it. So we see that we're actually, from our original, we're subtracting, all right, 3 over pi. Well, subtracting 3 over pi means we're moving all of our points to the left 3 over pi units, 3 over pi units. And so that's why we're moving it to the left 3 over pi units, all right, from that value. So we take that, and you always want to set that equal to our value because that's our outside, and we're going to have pi plus x. Set that equal to x, and we solve for then for x, all right, when we do that, okay? Or we solve for x, all right, when we do this. So, so right here, we're going to solve for x, and that's how we figure out our phase shifts. So we see then what are we adding to this value? We're also dividing by everything by pi, so it's going to be pi units less. That's what we have there. Okay, and you can also see that if you factor out pi is another way of doing it, and you can see what we're adding. All right, if we add this, the inside is actually the opposite of that. So hopefully that makes sense. All right, and when we're doing our different values of transformations. Next one, we're going to match our graphs. All right, it's number 11. To what we have here. And sometimes this is very, very hard to see for this one. I believe this is pi over 8. Okay, so that right there is, okay, pi over 8. Pi over 8. Now, the key thing is that you want to look for what is our what do we know about tangent and cotangent? So this is going to be the key thing. Tangent graphs always pass through the origin, and normally when you have a tangent of our original, that's going to pass through the origin, and you have vertical asymptotes here and here. So you have one at negative pi over 2 and then pi over 2. And so that's a tangent graph. A cotangent graph, all right, cotangent graph, and this is what you have to know. Cotangent graphs, okay, start at, all right, pi over 2, all right, that's where the 0 is, and then you go like this, it goes whoop. So you have vertical asymptotes here at 0, so x equaling 0, and then x equaling pi right here, okay? So we have these two values right there. Okay, so now the question is, what is happening? Well, we are changing this as pi over 8, so if you look at this, this is saying we're taking cotangent and we're moving it to the right, all right, right pi over 4, right pi over 4. Well, right pi over 4 of a cotangent would move this pi over 2 to, well, 3 pi over 2. Well, this is not. This is 3 pi over 8. So how do we get an 8 there? That wouldn't do that. All right. Tangent, once again, tangent starts here, but how do we get pi over 8? So it wouldn't be that. So now the question is, all right, what we have, oops, I'm sorry, cotangent doesn't look like that. That's where I'm all messed up, because cotangent goes the opposite direction. So you should have got that. Hopefully you were screaming at your screen saying, Mr. Gutchog, that is not what it should be. All right. But it should be the opposite direction. Okay, so that's cotangent graph. Apologize for that. So you have to know those. And so if we go over here for tangent, well, tangent, that means all of our values are going to divide by 4. So instead of having a vertical asymptote here, we have vertical asymptotes at negative pi over 8. And then we have another one at pi over 8. Well, in this, we don't have vertical asymptotes that are at these values. We actually have a point here, okay, a point right there. So this actually right here means this negative means it's flipped. So now that means it's going to go up like that, all right? And now originally then we're taking by 4, so we're going to take this and multiply by 4. So actually this is going to be 4 times 2 is 8. So this is pi over 8, and yes, that is the answer. So C will be the answer, okay? You could also put this in your calculator, all right? If you go to your window, all right, and you have this right here, just go and put in pi All right, change your window and go pi, all right, sorry, 2 pi. Okay, 2 pi with that. All right. You can kind of see that we want a scale of pi over 8, okay, because we have that value there, because that's one of the values we want to look for. Y-min, we can go negative 10, all right, to 10. We can kind of do that. We'll go by ones on right here. All right, and so if we go to y equals, we can see this. I'm just going to get rid of that right there. And so when you have those right here, we can start putting in these different values. So we can say, okay, negative cotangent. How do you get to cotangent? Well, it's 1 divided by tangent is cotangent. And we're going to put 4x inside of there. And we're going to graph this. And what you can see then, at all these different values, oh, what's going on here? Oops. Make sure our mode is in radians so we can actually get a good graph. All right, mode is in radians. All right, now let's try this again. Oh, there we go. All right, so that's a pi over 8. That's another pi over 8. All right, so that's pi over 8, 2 pi's over 8, 4 pi's, or 3 pi's over 8, 4 pi's over 8, 5 pi's over 8, and so on and so forth. And you can see how that's being graphed, all right, and how that matches the graph we have right here, okay? And so you can also see that. So just make sure you know what these values are. That's where you go to window, all right, and plugging those in. Once again, that change your scale to what you have your pi's. Okay, so hopefully that helps you out. Next one is find the least positive value for t, which d equals 0. All right, here's our equation here. And I have the one circled. Let's find out what that is. So if d equals 0, we're going to plug 0 in for d. And then we're going to solve for this, all right? 8 pi t. Okay, so we're going to divide by this. We can get cosine by itself. So we have 0 equals cosine of 8 pi t. Now, we're going to take the inverse cosine, because that's how we get rid of that. Inverse cosine of 0, we got 8 pi t. All right, so find the least positive value of t. So in doing so, our first value that will give us cosine of 0 is going to be pi over 2. So pi over 2 is going to be our answer here. Okay, and what we have then is we have 8 pi t. We're then going to divide by 8 pi, so t is going to equal, all right, pi divided by 2 times 1 over 8 pi. The pi's will cancel out, pew, pew, and we're left with 8 times 2, that's a 2 by the way, remember, because it's pi over 2. All right, so we're going to have 1/16 is what t is going to be. So that is our least positive value is 1/16. That's the first one we're going to have when we solve that, okay, right there. And you can find out what that value is going to be there. We can also go to our calculator if we wanted to. All right, go to our calculator if we wanted to. And we can find this out using our calculator. So if you go over here and you go to your y equals, we know that equals 0, so we can go and plug this value in here. So we can go 7, all right, cosine of 8 pi. All right, x is going to be our t value. And we'll close this parentheses. Our window, once again, we'll just keep that right there, and we'll graph this, okay? And we see this now. We're looking for the 0, and our first 0 that we have here is going to be that. And so it's going to constantly go all these different values are going to go on and on and on and on and on. But we're looking for that one little point right there, okay? That's our first value. And probably didn't want to go that much, keeps on going up and down, up and down. All right, so how do we find that one value? What's that intersection at 0? So if we go second calculate, we can find the 0, number 2. It's going to ask us for this, so we can go, keep on going. Come on, come on, come on, come on, come on, come on. We're going to get our left bound. Maybe we'll keep on going there. I have a really slow calculator, but you want to keep on going back over here and find that one value right there. Another thing you could do is if you want to just test, because you have a multiple choice test, you could just actually plug in the values and go to trace and see what the values are going to be. All right, and when you find this, I'm just showing you on this. So if we wanted to, I could just go trace right here. Makes it a little bit easier. 1 divided by 16. And you realize it's going to be 0, so that's our first one. If you go to 1 divided by 2, so we press trace or just put in our value, you realize we don't get a value of 0. That's way up here, so that's even on it. So you can go 1 divided by 4. All right, what's that value going to be? All right, it's going to be 7. And you can plug in all these values. 1 divided by 8. all right, we know it doesn't equal 0, all right, equals -7. And so you get all these different values, and you'll finally find the answer for that one, all right? So I'm going to try one more time, see if I can find, so I can calculate 2, so we can use this a little bit. All right, good. It's over here. So I'm going to go left bound here, press enter. So the left side is right there. I'm going to press over here again, press enter. All right. I'm just going to guess for me, and I'm just going to get it. And we get 0.0625, 0.0625, and that's going to be rounded to 0. So 0.60625, if you took 1 divided by 16, guess what? 0.0625. All right, so that's how you can verify that that's your answer. So 3 different ways using a calculator, also by hand, on how to solve that. All right, next one. Find the solutions of tangent 3t equaling square root of 3. Well, once again, we can solve this without our calculator. If we go over here, we can say, okay, tangent. All right, we're going to take the inverse tangent of the square root of 3, and that equals 3t. So inverse tangent of square root of 3, if you think of square root of 3, is going to be right here. Tangent is opposite over adjacent, and that's going to be 2. So what's opposite of that's going to be pi over 3, pi over 3 because it's 60 degrees. So we know 3t is going to equal pi over 3, okay? And what we know is that's going to be also, because where also is this going to be, tangent going to be positive, what's going to be in this quadrant as well. So if we go and add a pi, or n pi to that, we'll keep on getting all of our values, all of our different values, okay? And so we can actually, now we have to solve for t, so we're going to divide by 1/3, so we have pi over 9 plus n pi over 3, because we're dividing by 3, so we multiply everything by 3. 1/3, okay? And so now the question is, okay, now we got to find all the values from 0 to 2 pi, 0 to 2 pi. We know one of them is here. We found out that if we go pi over here, all right, in the third quadrant, we can get the next one, all right? If you didn't know that, you would have realized that that would have been 5 pi over here. That have been, sorry, 4 pi over 3, 4 pi over 3, and so you saw that and that. And so a lot of people would maybe have said maybe just this would have been the answer, but then you forgot to divide here, so you have this as your answer. However, we need all of the values between there. I mean, since we shortened it, we know that this would have to be the answer, but how do we get the additional ones? We just keep on adding pi over 3 to that. Okay, so the first one would be, and we get 9, so we have 3 pi ninths, and we can have the first one, it's going to be 3 pi plus 1 pi is going to be, all right, 4 pi ninths, and then we add a 2 here, would be 6, another additional one would be 7 pi ninths, all right, we add a 3 would be 9, would be 10 pi ninths, and I just keep on adding numbers. So if I add, so if n equaled, so how do we get this one? When n equaled 1, all right, here, when n equals 0, we just get pi over 9. That's when n equals 1. And n equals 2, we get 7 pi over 9. When n equals 3, we get that. When n equals 4, all right, 4. So 4 times 3 is 12, 13 pi over 9, all right. And then when n equals 5, we'll have, all right, 5 be 15, 16 pi over 9, and we have that. And those are all of our possible answers. We can also go to our calculator again, and if you punch in here, go to your y equals, and if we solve for this instead of equal to 0, all right, so we go from, so we put in, we just set this equal to 0, so a tangent of 3t minus the square root of 3 equals 0. We can go over here, and we can go to our calculator and punch in, all right, tangent of 3x, all right, so t is like our x, minus the square root, all right, of 3. And once again, my window, I have this right here. We can change it, but this should be okay. All right, and so let's just see when this graphs, all right, we see 1, 2, 3, 4, 5, 6, 6. We have 6 solutions because we have 6 zeros, and that's how we'd use, and we would find each one of those, or use trace, all right, and we can go just punch in like pi divide by 9, and see what happens. And we have a 0. Okay, we just punch in all those in our calculator to kind of verify them, but we can see that 1, 2, 3, 4, 5, 6. We have 6 values. So doing it without your calculator, doing it with your calculator, that's how we'd find our solutions. All right, same thing going here. We can do this with and without our calculator. If we do it without our calculator, we first want to take this sine of 2x, and we want to use identity. All right, this is a double angle formula, all right, which you'll have that on your sheet, or at least in my class, that's what we would have. And so sine of 2x would be 2 sine of x cosine of x. We then take that plus sine of x, and we set that equal to 0. One of these things, just like the other, what you going to factor out? Well, sine. We can factor out a sine of x. When we do that, we have 2 cosine of x plus 1 equaling 0. Okay, so each one of these factors would have to equal 0. So we say sine of x equaling 0, and then we have 2 cosine of x plus 1 equaling 0, which is negative 1 over 2 equaling cosine of x. And so now we solve this. All right, so sine of x equaling 0 is going to be at 0 and pi. That's cool. That's what x is going to equal. So when is cosine going to be negative? Well, cosine x sine y. So right here, that's going to be in the second and third. We have is going to be negative 1 and 2. So we have 2 right there. So what is going to be that? Well, that's going to be a radical 3. It's going to be negative square root of 3. So this angle is going to be a multiple of pi over 3, actually 2 pi over 3, and then another one, and this other one is going to be 4 pi over 3, and so we have x equaling 2 pi over 3 and 4 pi over 3 as a solution. And so over here, we're going to look for all those answers. Where is that going to be? 0 pi, 2 pi over 3, and 4 pi over 3, all right, for our answers. Okay, and so that's how we can solve those, all right? All right, with those different solutions right there. Once again, you can go to your calculator. So if you take that out and you punch this in here, and we can just actually punch in this value. All right, so if you want sine of 2x, all right, and we close parentheses, and we go plus sine of x. Make sure you're in radians and not degrees. So if you ever notice that something's really crazy, make sure you're in radians, not degrees. All right, because all these are in radians because you see pi's. Okay, but then we go to we got our y equals, and then we go to graph this, and we're going to graph from 0 to 2 pi. So our window's already there. So we see one of our answers at pi, or sorry, 0. We see another one's going to be right here. Okay, which I'm assuming is going to be the pi. Then we have 2 pi, or not the pi. And we have 1, 2, 3, 4, and then you see the 2 pi's, the final one, but we're not including that because it says don't include it. And so if you just want to trace this, you can just test out your answers. All right, we have 2 pi divided by 3, and we see that, oh yeah, it's going to be 0 right there. 2 pi divided by 3, here's pi, and that's supposed to be 4 pi over 3. Hello, 4 pi over 3. And that's how we can test out and find our values that way. You can also go find your zeros and just check all those out as well. Okay, and finally, all right, finally, number 28. Until 1990, the Leaning Tower of Pisa leaned, all right, in terms of from the vertical. When the standing away from the base, tower is obtuse. We had this before in one of our problems, obtuse. The angle of elevation to the top is 28.5. So, all right, you see my little drawing here, but if you didn't get this, so we have the Leaning Tower of Pisa. It's going vertical, but it is obtuse, so 10, all right, degrees this way. Okay, so there's the Pisa. We have 100 meters away. All right, you have a base of the tower, and so you have this. You have an angle of elevation going up that way. All right, and so this angle right there is 28.15 degrees. We have this one. This angle is going to be 100 degrees. Okay, 100 degrees. And so what we want to do is we want to figure out what this height is. Okay, what that height is. Okay, so knowing all this information, well, I have one side, I have an angle, and a side. Angle, side. All right, what's that? Angle, side, I'm sorry. We have an angle, all right. It's an angle, side. Angle, side. Angle, side. And if we're using angle, side, this is where we use the law of sines. All right, law of sines. We will have to find out this angle because by taking 100 plus 28.15, and we're going to take that and subtract that from 180. and then we're going to call this angle A. All right, angle A. Okay, and so we're going to use that to help us figure out the measure of angle A. So if you go over here and you check that out, and you take 180 minus 100 minus, all right, 28.15. We have that right there. We have an angle of 51.85. All right, degrees. All right, you can put that in your calculator or do it in your head, whatever you want to do. All right, so now the question is, okay, we have that angle, and we have this side. And we have this side we want to find and this angle. So we're going to use the law of sines. The law of sines says if I take the angle of 51.85 and make that its opposite side, which is 100, and set that equal to the sine of 28.15, and set that equal to h, which is the height of the piece that I want to find. And then I solve for h by cross multiplying. So I think 100 times sine of 28.15, and I'll divide that by the sine of 51.85, and that will equal h. So put this in your calculator. All right, I'll take my calculator out of here. All right, so you can see this. Okay. Now this is in degrees, so make sure you change your mode. Go down here. Go to degree. All right, I'm going to clear this for us. We got 100 times the sine of 28.15. All right, and we divide that by the sine of, all right, 51.85. Close parentheses again. Boom. 59.992. All right, so H is equal to 59.992 meters. That's what I was looking for, meters, and that's what the leaning tower piece is going to be. Okay. All right. Well, I hope that helps you out in understanding how to do some of these different problems. Good luck and God bless on your review.